What if the greatest mind in history didn't just understand time? What if he escaped it? Albert Einstein wasn't just ahead of his era, he seemed to exist outside it. A patent clerk with no lab, no connections, no credentials, who suddenly rewrote the laws of space and time. His ideas didn't gently shift science forward. They detonated it. He bent time, warped gravity, opened doors to dimensions no one else had even imagined. But where did this knowledge come from? Was it genius or memory? Intuition or recollection? Because sometimes it feels less like he discovered the future and more like he'd already been there. This is Infinite Mind, where myth collides with physics and the lines between legend and reality blur into one haunting question. Was Albert Einstein a secret time traveler? Albert Einstein didn't arrive in our world with a flash of lightning or the hum of future machinery. He wasn't discovered in a crater. He didn't fall out of the sky. He was born in Ulm, Germany in 1879. Quiet, reserved, misunderstood. By all appearances, he was completely ordinary. But there was something about him, something strange. As a child, he spoke late. His teachers said he was slow. He'd stare at compasses for hours, obsessed with the invisible force that made the needle move. While other boys were playing games, he was imagining light as something you could chase. If he caught it, what would he see? He eventually failed his university entrance exam and struggled to find work. By the time he was in his 20s, he was married with a child and working a desk job at the Swiss Patent Office in Bern. He spent his days reviewing technical documents and electrical schematics. No one had any reason to believe the most brilliant scientific mind in history was sitting in that room, let alone contemplating the foundations of the universe. But in his free time, he scribbled equations on scrap paper. He had no lab, no research funding, no scientific network. And yet in 1905, at the age of 26, he produced something that even today seems impossible. 4 scientific papers, each of them groundbreaking. One of them, Special Relativity, declared that time and space weren't absolute. They were woven together in a fabric called space-time, and that fabric could bend, twist, and even slow. Einstein wasn't just theorizing, he was writing an instruction manual for how time itself works, for how it could be manipulated, measured, broken. The more you moved, the more time bent. Travel fast enough, close to the speed of light, and time slows to a crawl. For you, minutes pass. For everyone else, years race by. Time travel to the future becomes not only possible, it becomes inevitable. So where did this knowledge come from? How did a civil servant, alone in an office with no formal access to cutting-edge research, leap so far ahead of the scientific world? Was he simply brilliant? Or was he remembering something the rest of us had yet to discover? Special relativity shattered the illusion of fixed time. But it was just the beginning. A decade later, Einstein took on gravity itself. In 1915, he unveiled general relativity, a theory so elegant and complex that even today, physicists are still unpacking its full implications. He said gravity wasn't a force pulling objects toward each other. It was geometry. Mass bends space-time and objects move along that curve. Planets orbit not because they're being tugged on, but because they're following the natural lines of a distorted cosmic fabric. This revelation didn't just reshape physics, it reimagined the universe. The equations predicted things never seen before: black holes, time dilation in gravitational fields, the warping of light near stars. And yet Einstein, calm and precise, predicted them all. But nestled within these equations was something even more outlandish. Something so bizarre, even Einstein himself didn't quite embrace it. In 1935, alongside physicist Nathan Rosen, he proposed what we now call the Einstein-Rosen bridge. a tunnel through space-time, a wormhole. On paper, it connected two distant regions of space. But others began to wonder, what if those regions weren't just far apart in space, but also in time? A passageway not only between places, but between eras. If one end of the wormhole was accelerated close to light speed and brought back, the time difference between both ends would shift. Walk through one end and you might emerge years or centuries, earlier or later. Time travel, not as fiction, but as a side effect of space-time engineering. There's a catch. To hold a wormhole open, you'd need exotic matter, substances with negative energy. We've never found such material, but quantum theory says it might exist, and that small fluctuations in energy could, under the right circumstances, behave exactly as needed. In other words, the laws of physics don't forbid time travel. They allow it. They even hint at how to do it. But no one has yet cracked the code. Or have they? Because in all of this, the math, the predictions, the insights, Einstein always seemed to be ahead. Not by inches, but by entire decades. Ideas that once seemed absurd are now used daily in GPS systems, satellite tech, and theoretical models of the cosmos. Maybe he didn't invent the future. Maybe he remembered it. Let's imagine something outrageous for a moment. Not as scientists, but as storytellers. What if Einstein wasn't a man of his time, because he wasn't from his time? In a distant future, time travel becomes real. Maybe it's classified. Maybe it's unstable. Maybe it's used only in the most extreme circumstances. But somehow, someone is sent back. Maybe they volunteered. Maybe it was a mission gone wrong. Maybe it was an accident. They land, or are reborn, in the 19th century. Their memories are fragmented. But strange ideas linger. They don't remember the blueprints, just flashes, instincts, the way light feels, the way time folds. They're obsessed with clocks, with the nature of perception. They ask questions no one else is asking. And when they grow up, they begin to write down what they know, not from textbooks, but from a memory deeper than language. This is the story some whisper about Einstein, not because there's proof, but because there's something about him that defies explanation. He wasn't just smart, he was off-axis. His ideas felt like artifacts from the future. When he proposed general relativity, scientists didn't even know black holes could exist. When he suggested light could bend around stars, we hadn't yet developed telescopes powerful enough to confirm it. But decades later, we did. And each time, the universe nodded. The theory was right. So where did it come from? Einstein famously said, "The distinction between past, present, and future is only a stubbornly persistent illusion." To most, it was poetic, but maybe, just maybe, it was personal. Let's say time travel is real. Then, so are the problems. The grandfather paradox is the most famous. If you travel back and stop your grandparents from meeting, do you cease to exist? But if you never existed, who stopped them? Then there's the bootstrap paradox. Information or objects that exist without origin. A future person finds an invention, travels back, gives it to its original inventor, who then publishes it. Where did it actually come from? These aren't just narrative devices, they're real questions buried in physics. Some theories suggest paradoxes resolve themselves, that time knows how to correct. Others say every change spawns a new timeline, a branching multiverse where both versions exist. And still others, the most haunting of all, argue that everything is fixed. That even if time travel is real, the past cannot be changed. You were always going to go back. You already did. And maybe that's where Einstein comes in. If someone traveled through time and gave the past the tools to unlock the future, wouldn't they look exactly like him? A man who arrived seemingly from nowhere, holding the secrets of the universe? A mind that bends space-time without touching it? And even now, over a century later, we're still working within his framework. Black holes, wormholes, gravitational waves. Every discovery confirms the trail he left behind, as if he knew exactly where we'd go next, almost like he'd seen it before. When Albert Einstein died in 1955, scientists removed his brain without his family's consent. They dissected it, hoping to find the secret to his genius in the folds of gray matter. What they found were anomalies, slight differences in the shape and density of certain regions, but nothing conclusive. Nothing that explained how one person could rewrite reality. Maybe that's because it wasn't just in his biology. Maybe it was something else, something harder to measure. Imagination. Because Einstein didn't build machines or run experiments. He imagined. He visualized. He ran thought experiments so vivid and strange that they led him straight into the heart of space-time. He wasn't a builder. He was a traveler. Not through space, but through concepts, through the boundaries of what was thought to be possible. And that, perhaps, is the most powerful form of time travel we have. Because here we are, decades after his death, still living in the future he mapped out, still catching up to the places he already visited, still wondering if, somehow, we're the ones following him through time. So, was Einstein a time traveler? Probably not in the science fiction sense, but maybe that's the wrong question. Because whether he came from the future or just saw it more clearly than the rest of us, Albert Einstein changed the shape of time forever. And in doing so, he left us a mystery, not just of physics, but of fate. Thanks for watching Infinite Mind. If this video stretched your brain in the best way, leave a comment below. If you had the chance to travel through time, would you do it? And more importantly, would you come back?